Words can't describe just how much I miss you whenever you're gone. I want you here beside me for eternity, shining your light like a sun. I try for you, baby, to take the higher road, to be someone you're proud of, but I've been lost lately. I don't know what is right or wrong. Ooh, I always like me better when I'm around you. Ain't no place I'd rather be. You got this energy that always surrounds you. It's everything I'll ever need. The devil on my shoulder's almost gone. Ooh, I always like me better when I'm around you. Around you, oh yeah. Call me some night when you got time. I won't be asleep anyway. 'Cause I just need one reason to keep on breathing. Tell me you'll come back to stay. I tried for you, baby, to take the higher road, to be someone you're proud of, but I've been lost lately. I don't know what is right or wrong. Ooh, I always like me better when I'm around you. Ain't no place I'd rather be. You got this energy that always surrounds you. It's everything I'll ever need. The devil on my shoulder's almost gone. Ooh, I always like me better when I'm around you. Around you, oh yeah. Lord knows how I try to be anything better than worst, but I can't get by. 'Cause I need you right now. Ooh, I need you right now. Ooh, I always like me better when I'm around you. Ain't no place I'd rather be. You got this energy that always surrounds you. It's everything I'll ever need. The devil on my shoulder's almost gone. Ooh, I always like me better when I'm around you. Around you, oh yeah.
Good morning, everybody, and welcome to the Routing Security SIG. My name's Jocelyn. I'm based in Australia, in Brisbane. I work for Amazon Web Services, and I'm the current chair of the Routing SIG for APNIC. My co-chair is Dee Ma from China, and he is there in the middle. Hi, Dee.
Hi, hello, Rod.
He is excellent co-chair. I'm very lucky to have him. Now, I'm a bit disappointed with the audience today. I know everyone's had a big Wednesday night out. So I really hope there's a lot of people watching on Zoom, because I put a lot of effort into putting the program together today. And I really wanted to round the program out and take you on a journey through a lot of concepts of RPKI. My goal is to make RPKI cool again, which I find it may have lost its way over a bit of time. So let's see how we go. My first speaker is going to be coming on Zoom because they're based in New York. Now, We didn't expect our first speaker. We have, in fact, found, Paul Wilson found their paper online by accident. And he sent it to the Routing SIG group and said, hey, this is quite amazing. You want to have a look at it? And I did. And I have to say that this is something that I haven't personally seen before in the industry. I've sat through many RPKIs over the years. I've sat through many routing securities over the years. I've sat through vendor presentations over the years of RPKI and how we should be doing it on their platform. This is the first time I've actually seen a paper written on a framework of RPKI or routing security, pardon me. A framework policy that you can take into your company that's holistic, that looks at all the areas that you can roll out routing security. And I felt that was really valuable. It could be a guide that all of us could use, and not just in a carrier level, but in enterprise and a government level as well. And they put a lot of effort into this framework, and that encouraged me to want to reach out to that author or one of those authors and see if they'd be willing to come to us today and talk us through that framework policy. And they agreed, so we're very fortunate. Additionally, I'm aware that those speakers, or this speaker, Priya, is very keen to hear feedback, because their goal is to make sure that this framework policy can be the most robust, the most useful to the community in general. So at the end of this, I'm sure they'll give you some sort of contact so you can give feedback and ideas, and please feel free to ask questions during the session. We really love to hear that as well. So will you please welcome Priya from Cable Labs, who's coming into us via Zoom. Thank you.
Morning, everyone. Hello from New York. So it's nighttime over here. But thank you, Jocelyn, for that introduction, and thank you all for inviting me to speak. I'm going to be sharing my screen, so hopefully you can see my presentation as soon as I pull it up. And just so you know, when I'm actually speaking, I'm going to turn my video off, because I don't know about you, but I find it extremely distracting to stare at myself when I am speaking. So let me see what I can do here. Okay. Are you able to see my screen? Okay.
Yep, Priya, yeah, we can still see you, just FYI, but you look great. And we can see your screen. We can see your screen in the big. I think we should leave you on there, because you've got such a great face, like for Zoom, and you've got a great smile. So can we leave you, please? But we've got your screen presentation.
Oh, okay, cool,
Yeah,
sure. All right. So, okay, all right, let's go. So as Jocelyn mentioned, I will be talking to you today about a cybersecurity framework profile for internet routing that Cable Labs, along with some of its collaborators, created. So we're calling this presentation Driving More Secure Internet Routing, just because we want to be fancy. So let's get right into it. I wanted to start off with a summary slide just to kind of set the stage for what I'm hoping to talk about. So as I mentioned, Cable Labs, its members, and NCTA, which is the Internet and Television Association, we jointly developed a cybersecurity framework profile for internet routing. I'll be calling it Routing Security Profile, or RSP for short. That profile was released about a month ago. So the initial release was published, and at the end of this slide deck, I have a QR code, which hopefully you guys will be able to get it to work. And a link to the actual framework, so you'll be able to download it yourself and see what it is we're talking about. So the RSP is a compilation of the cable industry's expertise. We aligned the RSP with the National Institute of Standards and Technology here in the US, NIST. I'm sure some of you guys are familiar with NIST. I hope you are. We use the CSF version 1.1. And the idea behind the RSP is that it provides a roadmap for any organization to drive more secure internet routing. The industry, I'm sure, along with all of you, have long recognized the threats to internet routing, and we have proactively sought to kind of address those threats both internally and then through broader industry technical fora, which is what we're hoping to do here. Our next step is to take the routing security profile to the broader internet community, which includes all of you, to drive awareness and to advance this work. So as Jocelyn mentioned, we welcome feedback from all of you once you've had a chance to look at the profile. And so let's get into it. Some of you may ask who Cable Labs is. So I'm just going to do briefly a few slides on who we are. So Cable Labs is a nonprofit. We are a global broadband industry R&D lab for next generation network technologies. Our members, we have 60 plus members, which include leading cable operators over 35 countries, including countries in Asia and Australia. And we serve, our members serve over 150 million households and mobile users. So hello to our members over there. The technologies that we look at, oh, wait, oops, sorry, let's go back. The technologies that Cable Labs, our R&D folks look at are a wide range of technologies. So we focus on fiber, we focus on convergence with wireless technologies, of course, the hybrid fiber coax. We also do work in immersive media, in security and privacy, which is one of the aspects that we're focusing on here today. Also doing R&D work around quantum and AI, and of course, unlicensed Wi-Fi. Our technologies are used by over 500 million people every day. So that was a little bit brief background about who we are. So how did we get to the routing security profile? I'm going to give you a little bit background about how we came about it here in the US. So in the US, and I would love to know your perspective, possibly in the Q&A, on what you see internationally. Here in the US, we've had increased governmental interest and focus on routing security over the past 2 years or so. One of the US federal regulators, the US Federal Communications Commission, issued a notice of inquiry back 2 years ago around secure internet routing, and had a workshop about a year ago focusing on Border Gateway Protocol, BGP security. And so there's a lot of interest from the regulator on kind of what to do about routing security from that perspective. We also have here in the US a national cybersecurity strategy that was issued also about a year ago. BGP was also called out as a vulnerability. And so the implementing plan also had a focus on BGP. So there's been a lot of interest around routing security over like the last year or so. And then of course the ongoing work that the NIST has been doing around cybersecurity. Last January, they issued a concept paper in preparation for their release of the Cybersecurity Framework version 2. And in that concept paper, they had a call to action to submit examples of profiles that were mapped to the CSF that was intended to address cybersecurity risks that had like a particular particular business activity or operation. So that is what led us to form a working group. This was also a working group that was actually already in existence at Cable Labs, but we had our members who you see here who were participating in this working group work together jointly to create the framework profile that we'll be talking about today. So what is that profile? So the routing security profile is a framework. So the idea there is it's intended to help organizations as they're looking through risk management strategies to improve security and managing risk specifically for internet routing. It's one key piece, as it's noted here, of a larger critical infrastructure cybersecurity puzzle. It is not the only piece. So want to make that clear. This isn't going to be the solution for everything, but it is intended to be helpful to organizations as they're doing their risk management. So as the next bullet point says, the approach is from a holistic risk management perspective, which is similar to what the cybersecurity framework itself is does. So we took that and focused it again on routing security. The idea behind the profile is that it is applicable for use by any autonomous system operator that's large or small, who's looking to enhance their routing security. So as I mentioned earlier, the security profile is based on the NIST cybersecurity framework. I have version 1.1. Hot off the presses, CSF 2.0 was just released on Monday. So there's an updated framework, but all of the work that we have right now for the profile is based off of what was existing at the time, version 1.1. So for those of you who are not familiar, the CSF consists of three main components: the core, implementation tiers, and profiles. So as you can see here, the definitions for what the core is it provides a set of desired cybersecurity activities and outcomes using common language that is easy to understand. I'm going to skip implementation tiers. You can read the definition and then focus on profiles. The definition for that, which is that those profiles are primarily used to identify and prioritize opportunities for improving cybersecurity at an organization. So let's focus a little bit on the goals of the routing security profile. So the idea there is the profile serves as a foundational tool for network engineers, IT managers, cybersecurity professionals, any decision makers who are involved in network security risk management. The idea there is that it is a tool that can help evaluate, implement, and help these professionals manage their organization's routing security policies. The idea there too is that it's intended to be adaptable and scalable. So just as the CSF itself is customizable, this profile is also intended to be customizable for specific organizations' network environments. So the idea there is to help AS operators work to fortify their own networks, and then in doing so, also contribute to the broader goal of creating a more secure and resilient global internet infrastructure, since as we all know, we are all part of the global internet, and each of us has a role to play in that. So the scope of the routing security profile is also important. So as mentioned earlier, the focus here is only on routing security. It does not cover general cybersecurity topics that are unrelated to routing. It also does not cover any kind of security aspects of other network layers or services. What it does include is routing security within network infrastructures, including a network provider's routing infrastructure, the security infrastructure that supports the routing security, external routing peering interfaces, and external routing information registries. So you can see here the list of some of the focus of the routing security profile. So BGP, IRRs, AS path filtering, RPKI, ROA, ROV, and OAM systems. So how do you use the routing security profile? So the profile itself customizes the CSF 1.1 structure, and what it does is it maps routing security best practices and informative references to the applicable categories and subcategories of a CSF core function. There are 5 core functions, which you'll see in, I believe, the next slide, and I can explain what those are. But for each of those core functions and each function category, there is a table that lists subcategories of that function, and then their applicability to routing security, and then any associated informative references. So the informative references that we've include things such as NIST standards, IETF, RFCs, and CableLab's head-issued RPKI best common practices. And so it includes links to that where appropriate. And in these tables, people can link to those appropriate standards, or at least have references specifically that point to where you can find information related to that subcategory by going to those informative references. The folks who are intending to use the profile are urged to actually review all the subcategories, including the ones that are not listed as applicable to routing security. Because as your organization is different, you'll need to look at it in the context of your organization and then adapt and accommodate as needed. So these are the 5 functions that we mapped to, and these are the 5 core functions that are listed in the CSF version 1.1. So that's identify, protect, detect, respond, and recover. So for the purposes of IP networks, we have used identify as to identify systems, assets, data, and risks that pertain to IP networks. The protect function is to protect IP networks by performing self-assessments adhering to cybersecurity principles. The detect function is to detect cybersecurity-related disturbances or corruption of IP network services and data. Respond is to respond to IP network or data anomalies in a timely, effective, and resilient manner. And recover is to recover the IP network to proper working order after a cybersecurity incident. So here's an example of the table that I had mentioned, that's the profile. So this particular example is the identify core function, and the identify core function has 6 categories. The asset management category is the first of the 6 categories. The others are business environment, governance, risk assessment, risk management strategy, and supply chain risk management. I've only focused on the very first category as an example. And in this category, there are 6 subcategories, which you can see listed here. So the ID.AM is ID for identify, AM for asset management, and then you can see the 6 different categories. So as I mentioned, the second column talks about the applicability of this particular subcategory to routing security. And you can see through here how we've said that, or at least the recommendation that can be found in the informative references as to what needs to be done for each subcategory. And in the very rightmost column is the informative references. So this particular informative reference that's cited here is the NIST Special Publication 800-53, revision 5. And then you can see next to those several other categories, and those are references that can be found in the special publication itself. So for example, CM stands for configuration management, PM stands for program management. You can see a little bit further down, there's an AC, that would be access control. So you can see all of this specifically pointing to where in the publication you can go for additional information about the particular subcategory. So as I mentioned, this particular category had 6. So this is just the remainder of that particular category. And as you'll notice here, under IDAM5, we've noted that this particular subcategory is applicable to routing security, but it does not include routing specific considerations. So this is, as mentioned, something that organizations may want to look at and see if there is something in your network environments or your organization where you may have to follow up a little bit further here, even though there isn't specific routing specific considerations included here. So this is a lovely diagram, just another way to kind of categorize the asset management subcategory. The idea here is that an AS operator would need to identify and produce an inventory of all of the assets related to internet routing. So those would be including those within an AS, such as BGP speakers. You can see here like R1 through R5. Outside of the S, and you can see some of the examples of that, which would be like internal OAM systems, external peering BGP speakers, RPKI assets, and accounts in RIRs and IRRs. So that's just a graphical example of an asset management inventory. So here are a few key takeaways. So as we all know, threats to internet routing are diverse, persistent, and changing. A lot of our current efforts are focused on developing and implementing security controls. RPKI is one of them. Routing security, our routing security profile approaches routing security, as mentioned, from a holistic risk management perspective. And I said we are hoping that it's applicable for use by any AS operator. And also, as I'd mentioned earlier, it's a tool we hope that practitioners and network operators can use. And it's helpful for any size organization, large or small. We particularly are hoping that some of the smaller operators get a benefit from this because, when you're first starting out, you really want to be able to find something, and there's tools and references all over the place. And we're hoping that having this tool would be a starting point for folks who are just looking to get at least a mapping to some of the important informative references that are focused on internet routing, that it would be helpful to some of the smaller operators who really are, trying to comprehend and just, get all of the information into one starting point to just to start off with, just to begin. So, of course, the routing security profile and all of the underlying technical controls have to be agile. We have to continue to evolve. The landscape is constantly changing, and so it needs to be updated fairly often in order to be able to address these changes. So what are our next steps? Our first step is to engage with the broader internet ecosystem stakeholders, and that would be all of you, so that you're aware of this profile and also to help us improve and advance this work. So we would love to hear from other AS operators, ISPs, cloud service providers, because the idea is that this can be used and adapted and customizable for these other organizations that we have listed here. So as we know, NIST CSF 2.0 is just released. So the intent is to update this first version that was just released about a month ago based on feedback that we received from stakeholders, and also to reflect any applicable changes to the underlying CSF 2.0. So that is our intent. This is an ongoing work, and we would love to get your feedback on this particular profile and any thoughts on that. So that is all I have. This is the QR code and the link here for our profile. So I am going to keep this up for a minute and just Jocelyn, just ask if there are questions.
Hello? Okay. Priya, amazing. And I really appreciate you dialing in from New York late at night to beam your beautiful face into APAC and AP Nick for us. If it's okay, I'm going to start with the first question because I am curious. Are you aware that of this framework policy actually being trialed inside any organizations, or is it too new, nascent at this stage to have seen anybody actually try to do it in real life, or where are we at with that situation?
So I know some of our member operators, through their participation in this working group, have actually found it helpful and useful. And we had one of our mid-size operators when we announced the profile talk about their use of it. So I think through the working group, through the process, they were able to find that some of the informative references were very helpful as they were deploying our PKI. So I have not heard specifically from others, as we're hoping to hear back actually from folks who may have found it useful. But I can tell you that within our working group members and some of the operators that we've dealt with, just working within the group and developing the profile and seeing it has actually been very, very helpful and useful for them.
That's really good. And I think, as you evolve, we'd love to hear that feedback into the routing security SIG. We have a mailing list and that sort of information or studies that you might get knowledge of, I could feed in for you so we can also get that insight, because the results are also really, that's what we want to see and hear and learn from as well. Now I'm going to open the floor. We've got somebody at the microphone. Please go for it.
Yes, we have a question here online from Shubham Saran. So the question is, how can an internet exchange implement this in their environment?
So that's an IXP, maybe.
Yes. How an internet exchange can implement it in their environment?
So I think the idea there is to look at, so the framework is intended to be high level. So to read through kind of the different functions, and the first one obviously is to identify. So at a minimum, I think having the identify and figure out what assets are relevant and what you would need to look at is helpful. As far as like how else to use it, the idea is that it has maps to particular functions. So if you need help in trying to come up with a strategy to implement for one of the other core functions because you had an incident, I think there's helpful information that points to references that you can go to figure out how to address that. I think that in the profile itself, we did include additional information. So there are additional resources that talk about deployments and how people have deployed and recommendations for deployment. I think I'd mentioned that Cable Labs has an RPKI best common practices document that we issued, I think 2 years ago at this point. There is a link to that in there as well. So that might be helpful if people are interested in RPKI deployments. I think the idea is to look at it and see how it can apply to your particular organization. And if there's a particular category or particular question about a subcategory that is not necessarily in there right now that may be helpful and applicable, we're open to suggestions and feedback on where we can include something that might be helpful for an IXP.
And that's right. So if you scan that code, correct me if I'm wrong, Priya, but I believe it'll take you to the actual blog post, which includes the paper that you could download, and I have a copy on my desk as well. So download that, but it's also got a link so you can contact and feedback. And it's all contained in that blog post URL. Yeah, one-stop destination for that. Do we have any more questions? Anything online? Anything further for Priya, or can she log off for the day? All right, Priya, you may go, and thank you so much again. I really appreciate your help. It was lovely to meet you and work with you on this.
Absolutely. Thank you all. And we look forward to hearing from you and continuing to collaborate in the future.
Bye.
Bye.
And I also would like to thank a colleague back home who helped me with the presentation on Priya, Shay Charlie in Sydney. If you can hear me, hi. Thank you. All right. Next on the journey of RPKI this morning, I would like to introduce you to Phil from Vocus in Australia. So the reason I invited Phil to speak is because probably 2 or 3 years ago, Phil spoke at AusNOC and he explained his journey at Vocus, which is one of the larger carriers in Australia, as to how they were going to implement RPKI. And they were in the early stages of implementing and what they were doing and what they were addressing and why they were addressing. And a few years ago, this was still quite a new concept in Australia, and Vocus were one of the first to successfully implement it. So we were quite interested in that. Now, they've finished that implementation. It's completed, and well done to Vocus for doing that. So I'm really interested to hear from Phil to come back and say, how did it go? What happened? Did it work? What went wrong? What happened with the vendors? Like, there's got to be a lot of hiccups along the way, because all of you are going to be doing it or in the process of doing it at some stage. So I'd like to hear from someone that has, and so we can all learn from that. So I think it's going to be a really valuable presentation. I'd like to welcome Phil.
Awesome. Good morning, everyone. I'd like to thank Jocelyn and the remaining board for inviting me here to talk about this. Yes, as Jocelyn said, I'm Phil. I'm part of the IP operations group at Vocus in Australia. We are primarily an Australian ISP. I'm not here to talk about the RPKI platform because hopefully everyone in this room knows about it and why it's important. If not, you can go speak to Jeff, who's over there. So I just want to talk about how we as Vocus implemented this platform and how we ventured into it. Awesome. Cool. So we had a number of requirements for this platform. So the Vocus network is a multi-vendor network. This is primarily due to the way Vocus has grown through acquisition. We have routers from Cisco, Juniper, Nokia, and Arista spread out across Australia and in some parts internationally. The solution we deployed had to adhere to RFCs and work with all these vendors. We wanted a common platform, a common communication method and deployment template that we could use across all our platform. So originally we wanted to okay, let's make this secure because everyone likes secure transport. However, a whole bunch of our network is GNOS based. They do not support it and still currently do not. They don't see it as important. I'm neutral on that one. We have routers. Sorry. Yeah, so ideally, yes, we want to do SSH TLS. Doesn't need to be encrypted. I'll leave that up to you guys. The information is all in the public domain. Up to you. Our validated caches lived in a central management domain. We chose to keep this central, and they're behind strict hardware firewalls with strict ACLs. We only want our routers to be able to talk to it, help our security, prevent any DDoSes that you could get. We made use of existing automation platform. In our case, we use Puppet to deploy and maintain this software on our validators. This meant that we were able to keep configuration consistent between the multiple servers that we have. And I'll go into that a little bit more shortly. So, validator software. These are the main ones that are out there currently on the market. We tested out a number of these, plus some more that have since dropped off. Primarily, these all run on Linux and BSD. I don't think I know of any that run on Windows. We tested out a number of validators in early 2020. So that's when we started this project. After initial testing for stability and consistency of data, we actually originally chose the NL NetLabs Routinator, as well as a RIPE RPKI Validator 3. So we were like, cool, chose 2 validators. Our mission was always for geographic redundancy. So we deployed the 2 validators in 2 different locations. We had a pair in Sydney and a pair in Melbourne. They were our main states within Australia. We just deployed these on Linux and in a virtual environment, and we chose to run native binaries. We did not bother with Docker. We had dedicated VMs for these. We was just like, keep it simple. As we were going throughout our journey, which I'll keep talking on later, we noticed the more routers that we had talking to the right validator, the more unstable it became. The GUI would often stop responding, and it would also fail to process new TAL files, which is great. This wasn't just common to us, and others had spoken to had experienced similar. So 2022 at the start of 2020 is when we started this. In July 2020, RIPE actually stopped any development on their validator, and it became end of life. Great. We were like, cool, 5 months of testing this out, back to the drawing board. A lot of you probably know Job Snijders from NTT at the time. We were talking to him about this process throughout it, and he was a big advocate for the BSD one because he wrote RPKI client. We tested that, and we decided to roll that out. RPKI client is a very light application, and we simply execute it every hour at different times using a cron job. RPKI client spits out the process VRRPs in a JSON file to the local computer, and we originally used GoRTR by Cloudflare. Here we go again, open source software, stopped developed, Lewis left Cloudflare, so we're like, great, choose something else. In the end, we went with StayRTR, which was just a pure fork of GoRTR, so it was actually nice and easy swap. Cool. So here I am talking about how we did it. So we had location 1 in Sydney, we had Routinator RPKI client with StayRTR, and the same in Melbourne. Geographically diverse, different compute, different firewall, different network segment, made it all nice and easy from a redundancy perspective. The one thing we did notice over time, the more and more these got loaded up, was our boxes in America. They were, let's just say 100 milliseconds round number, response time back to our caches in Australia. Our Cisco NCSs at the time would often time out. So we had to play with the keep alive statements and just extended it out a lot longer. Because again, it wasn't mission critical traffic. It was all fine. So timeline, cool. So you can see back in February 2020, so it was actually Apricot in Melbourne, right before or almost the start of Apricot. COVID is where we had the kick in the butt from the whole industry. And thanks, Nick, for that, to start this process rolling. So we spent a number of months, because what else do you do in lockdown? Australia was in, Melbourne in particular was in lockdown for felt like 6 years. We spent a lot of time signing our rowers, cleaning things up without actually even before deploying validation on our network. Our priority was to sign our routes. It's not that hard to do. And then during that time, obviously, we were testing validators in our lab. And then again, I can say, so Vocus runs a number of different networks. In particular, 4826 is our primary network, transit network. Behind that is 9443. That is our eyeball customers. So we actually, in August 2020, decided we're happy with this platform. It was running stable. We went and turned on validation in 9443. So we were blocking all invalid routes. So during this process, as I was talking before, we did a lot of cleanup. Not only did we want to sign our routes, we also looked at our routes from a historical perspective. Why are we advertising small aggregate summary routes out to the internet when we should just be advertising our /16s, 15s, whatever? So we spent a lot of time myself and another lady in Melbourne cleaning this up. So you can see the graph down the bottom. We went from just around 400 routes originated to around 150. So those routes, they weren't our routes disappearing. It was purely we removing the smaller routes just to keep summary routes. Whilst we were doing this, we also spent a lot of time reaching out to all those nasty people on the internet, apologies, who create proxy IRR objects. Our preference was we own the routes. We should be the one with the IRR object in the WHOIS system. So we reached out to RADDB, Reach, NTT, Level 3 and so forth to go, hey, I own these routes. Someone else created this. Please delete. I think I looked through my email box. I sent around 80 different emails to RADDB alone, going, please delete all these routes in that period. And I've obviously kept on doing it because we found that we deleted, someone would go and create it again. Kind of got quite frustrating. So yeah, that and RADDB, to their credit, were very good and very quick at doing this. So back to our timeline again. So once we had all our records cleaned up, we then proceeded to configure all our core routers talking to our validators further. Again, as I was saying, our priorities was sign our routes first, clean up our routing table, then look at the router perspective to get that talking to the platform. So as we did this, we were not dropping routes because we hadn't yet told our customers. What we did do though, is on import from all our transit downstream customers peering, is we tagged the routes depending on whether they're valid, unknown, or invalid. This meant that our customers or ourselves, we could monitor the invalid routes in our network. This was handy because RPKI at the time was fairly new. We actually had a number of our downstream customers that were sending us invalid routes. We were able to use this data before publicly announcing to the world that we were going to drop to go and help handhold these customers. So that actually, for us, that was a huge benefit because again, if you can treat your customers right, it makes it great long-term. So the main reason for all these customer invalid routes were actually generally to do with their invalid length. People assigned a route as a /20, but they were also advertising /24s. Would it have broken the internet for them? Probably not. But again, no one wants invalids out there. So at the start of 2021, after we had communicated to all our customers, and I think we had the number down to only receiving 3 invalids from around 60 at the start. We did a blanket communication to all our customers going, we are doing this in 60 days' time. Then on the 16th of March in 2021, myself and a few others went around to all our routers and blocked invalids. This was great success for us. That simple? No. So we learned a number of these lessons across that. As I said before, open source software, great, amazing, it's free, generally has good support. But if someone leaves a company or someone decides they don't want to do it anymore, support on that stops. So we said at the very start that Ripe dropped their validator support. And also Lewis, when Lewis left Cloudflare, GoRTR remained unmaintained. We as Vocus try to stick with maintained software for security reasons, and so should everyone else. And again, with the Ripe validator, so thanks Ripe for dropping this. It was built in Java. We noticed the more we added load to that, the more it crashed. And again, clean your IRRs. So AppNig make this very easy to create these objects in the portal when you sign the route. So limitations. Obviously, multi-vendor makes it fun. As we were doing this in 2020, Cisco was on quite old software. We found in Cisco, unless you were running 671 or above, you couldn't actually specify the source address of the RTR session to your servers. So that meant if your router has multiple exit points towards that, it would pick one depending on the path of the day. This, from us, from a security perspective, made it hard because we wanted to lock on our firewalls in front of our validators down to our loopback IP. So we, during 2020, also went and rolled out some software upgrades across our network. Again, we were locked at home. What else is there to do? We also found early in the days of Cisco, if the session to the validator was lost, the cache was not rebuilt locally. We actually had a recent experience of this earlier this year as well. Apparently Cisco had resolved it. I'm not fully convinced. Stale sessions as well. And of course, Juniper with SSH only. So we use a number of different tools to monitor for our invalids. If anyone has Google peering or caches here, they provide a portal. They give you reports, or even HE does, going, you are announcing this invalid route. We got confused because we were announcing the invalid route outside our network. We were like, that makes no sense. We validate everything. On one of our routers where the customer was connected, we noticed this route here was being reported as wrong. It was originating on the routing table, so I should have included that, from 58460. But the rowers were only signed from 49981. We were like, what is going on? Digging into a little bit more, we noticed one of our validation sessions to our second Sydney box had been up for 15 weeks. I was looking at this at the time going, that's impossible because just over 2 weeks ago, I updated all this software. Again, we found another Cisco bug. Still actually waiting for Cisco to tell us how to fix this. Please, Cisco, fix your stuff. So how do we monitor that? We're not perfect. We're learning as we go. So some tools that we use is, it was spoken about in another session the other day, we use a tool called BGP Alerter. BGP Alerter, great tool, free from NTT. It just monitors, we monitor ASNs and all our routes. So we know straight away based on route views collectors where these things are going to pop up. And we also know when we're suddenly announcing an invalid. Super handy tool for ops to see straight away you've got something wrong in your network. We also use just simple Grafana dashboards. There's templates out there for Routinator and RPKI clients. So one of the things that we've learned as well for these connected clients is we now, as of a few weeks ago, monitor our connected clients on our caches because we're like, we don't want that instance. Suddenly one router drops off one. There's not an SNMP for that. There are some syslog messages, but not really that helpful. So we now monitor if we drop a router off our validators and we know fairly quickly and we have to go digging. Yes, so we've, as I said before, we do BGP Alerter. We've also have set up just a virtual MX. It was easy in our environment. And on that as well, every couple of days, we can log in and see if we're receiving any invalid routes from our network. We treat that BMX as an external ASN. We just send our route table to it and see what happens. We chose Juniper A because I'm a Juniper fan, and B, they seem way more stable than Cisco for RPKI. Cool. So in 2022, we, like many other different companies as well, decided to update our looking glass. This was all part of the project. Re-rolled out Hyperglass, but on that you can easily see you've got a green tick box. So we were able to use this tool for our support teams internally initially until we rolled it out public. And then our customers can also see if they're valid or not. This is just running on a Linux box for us, talking to some VMX routers as well. And that's about it. So it's quick. Does anyone? Any questions from anyone?
Hello. Well done, Phil. Thank you so much. I'm a little disappointed about the bugs you're seeing in the vendors, yet the vendors keep getting on stage at Ausdog and telling us how amazing their RPKI support is. But so good to hear the practical reality of what's going on inside a carrier network when you try to do it, especially a multi-vendor one when you've had so many acquisitions as Focus has over the years, for sure, right? So who's got questions for Phil? Anyone that's come across similar bugs or is about to try to implement with similar vendor hardware or anything that they'd like to discuss with Phil while we have him?
Yeah, I
You.
have got a question for Phil.
Sure.
With my culture head off. So, how many RPK reliant party server are there deployed in your network? What
How
I'm
many
getting at is-
validators or how many
Yeah,
routers?
validator.
Yeah, so we have 2 in Sydney, 2 in Melbourne. Yep.
And do you use cache server that provisioning RPK validator data to routers?
No, so what we do is all the validators are self-contained. So the cache is all local.
Oh, okay.
And what we do is the 4 validators, we try and actually update them 15 minutes apart. So everyone updates every hour. We try and separate those every 15 minutes, because if we find a bug, we figured hopefully within the hour we can find it.
So based on your operation experience, do you think it's a good idea to use a centralized 4-function RPK reliant party server and with some distributed cache server?
Yeah, so that's
Deployed on the
something
network.
we looked at. So with, for example, our PKI client, because it's the one doing the validation and pushes out the JSON files, and you could deploy your RTR stuff out in the world. We looked at that. For us, it wasn't really valid. We wanted 4 separate sources of truth, because if we had one source of truth, we could see more what was happening previously. It crashed without us knowing. We wanted to make sure that we were always up to date as much as we could. Yeah.
Thank you.
Hello, go for it. And can you please let us know where you're from, just out of curiosity?
Yes, hi. Is he on?
Yes, it's on. It's
Okay.
on.
My name is Natalie. I used to work at RIPE NCC. I was responsible for the sunset of the RPKI validator. So it was good that you had 5 months to move over, and we agree that it was in a state that it wasn't good enough. What my ex-colleagues still see at RIPE NCC is that there's still 150 networks out there that are running the RPKI validator. And that is alarming because it is by now 2.5, 3 years unmaintained. So this is a call out to the community. Like, if you still run that RIPE NCC RPKI validator, please move away.
Please.
Thanks.
Thank you. Hi, what's your question?
Hi, I'm Prakash from Meta. Thank you so much for sharing. This is really cool to hear about the process of implementing it. We heard, I think, in previous sessions about trust anchor issues. So when there's partial VRPs or when trust anchor goes down, have you had any experiences with this, or like was this a problem that you encountered?
We do, and there's been a number of advancements in Routinator. The team at NLNet Labs are actually amazing. If you guys run a Routinator server, I actually recommend they have a Discord channel. with a lot of their staff and community are on. So they talk about this a lot. In the early days, I think we saw it once in real world where it actually had issues for us. But in terms of now, they've seemed to have put enough fixes in the software code to catch that and to not process it. Does that make sense?
Yeah.
Yeah. There's been a lot of advancements and a lot of changes to the RFC about how to process when that happens.
Gotcha. Okay.
Yeah.
Thank you.
Yeah, I think this day and age, it's not something to worry about. The good thing is BGP Alerter will actually alert on that too. So you know.
Thank you.
And
That
we
was a
should
good
note
question.
that we don't, if the route is unknown, we do not drop it. So if all our caches went offline, we would just open the floodgates.
Thank you for your question. Anybody else? Oh, we've got Phil. No, Phil, well
Awesome.
done.
Thank
Thank
you.
you so much for coming and doing it. All right, so everybody be prepared. We now have Terry Switzer from APNIC, and guess what? He's got the results. He's got all the data. He's tracking all of the locations, countries, regions we are from, and some of us are going to fail. Some of us are going to be pleasantly surprised. I really hope Australia gets through this unscathed. So I don't hold high hope, but yes, it's let's look at who's doing what now. It's the results of presidential election. No, of PKI. Okay, Terry.
Thanks, Jocelyn. Okay, just wait for, oh, there it is. Good. So those of you who don't know me, I'm Terry. I'm the Training Delivery Manager for South Asia and Oceania at APNIC. I'm also a bit of a buff when it comes to doing data analysis. I love throwing things into Postgres databases and coming up with insights from data. So I'll be relying on that, and I'll also be relying on some of Jeff's work today as well. So let's go through. So boilerplate, I have actually put the schema and the raw data for this online, so you don't have to rely on me to tell you what is going on with this data today. And of course, the main thing is this is a capture in time. So I did this in the middle of the day, Aussie time, on February the 7th. So if things have changed since then, please note, this is a point in time capture. And of course, a little bit of the schema there, you can see I've been working with lots of SQL, obviously Postgres. So data sources, very simple, read views, great source of data. In this case, I have narrowed down my root view to only Singapore. I don't really want to try to process root views from everywhere. Singapore is a great proxy for routes across Asia Pacific because it's more or less geographically and symmetrically and also latency central to the region. So it makes a good source of data as far as a particular view of the routes is concerned. You will notice the network counts that come up later that, root view sees more than what's normally in the public or in the global table. So keep that in mind. And of course, the other source of information is the 5 regional internet registries route objects and what they are publishing as RPKI data on that day. And that's a simple use of Job's command line client to dump everything into a CSV and import it into a single table. Very easy to do. And of course, if you're unaware of it, you can also get some raw data from FTP at all of the RIRs. And my main import there is just to tell me geographically where these prefixes are supposedly coming in from. The caveat there is the allocation will have a 2-letter ISO code for the country. It's normally where the member is located by HQ, not necessarily means the subnet or the prefix itself is in the same country, but it's a good proxy. At least it gives me someone to point a finger at and say it was France or it was Australia and so on. So very simple data structures, and these are exactly what the raw data looks like. I've simply constructed them, done a copy from, brought them into the database, and then started working with the data straight away. So those of you who are not familiar with SQL, I apologize, but I've tried to make things very obvious with what I'm doing, including showing you the queries as well. So As far as our signed routes are concerned, on this day, I managed to find 500,000 signed routes. So that's IPv4, IPv6 combined. And of course, the actual routing table, you can see there, it's 1.85 million routes. This is because we're getting routes from various diverse sources in SG. So they're not unique routes, they're just a number of different routing entries. But taking that with a distinct prefix in mind, you can see there we've got nearly 1 million IPv4 routes and over 200K IPv6 routes. Now this means in Singapore, in that particular route views instance, it's actually seeing more V6 routes than normally is appearing globally. So obviously SGIX and Equinix IX and other places in Singapore are deaggregating locally to somewhat extent. So fair enough. Yeah, it just means that we've got a few extra prefixes in the data that may make things more interesting for us with doing analysis. And we've also got a breakdown there by trust anchor and also protocol. So those of you who are not familiar with RPKI, hands up. Good, I'm going to skip that slide. Done. Okay, let's have a look at the raw data. So this is ROAs. This is signed prefixes. As you can see on the graph, we've only got really one big red area. I believe C and Nick are actually moving on this now. So the good news is if you're worried about China not signing routes, C and Nick has actually got something up and running. So this is good. There's lots of green here. Green is good on Jeff's graphs. Maybe. So progress reports, yeah, we're doing well. Oceania is actually doing really, really well for coverage, 80%. So that's impressive. As far as Asia is concerned, you can see there's a very steady climb. I think the only thing that we worry about with RPKI in general, as long as on the left-hand side it's low and on the right-hand side it's high. If the graphs are going in that direction all the time, we're making progress, which is good. Big smiley face, everyone. Thank you. ROV, not so good. Signing rowers is great, but you do need someone else on the internet to consume them and use them for validation. So this is not good news for validation. We're lagging behind in most places. Australia gets a tick because AS1221 does their job, Vocus does their job, Aussie Broadband and so on. And of course, Taiwan, also in the green. This is good. Means there's lots of validation happening there. And there's not much other green there to speak of. So this is our concern. We need more people to deploy ROV. And as you can see, the graphs, they're not doing that nice steep climb left to right. They're actually quite volatile and going all over the place. And even with Jeff's update, with separating out the V6 and the V4 data, that V6 validation looks good, mainly because, again, it's Telstra and a couple of other Australian ISPs carrying the water on that in Oceania. So again, kudos to the Aussies, but we need everyone to emulate that. So one thing I did notice that was missing from Priya's talk was discussion of something called BCP 185. So this is your best current practice document for RPKI. It's a combination of an old RFC written by Randy Bush and a new RFC written recently by Job and his crew. This is all about minimalizing your ROAs. That is, what you advertise, you sign. What is out there in the global table, you have signed, and no more than that. Now, the unfortunate story is we've actually got people signing routes, they're signing their ROAs, and they're using extremely long prefixes and extremely long max lengths, multiple prefixes, supernets, which go all the way down to 128 and IPv6, which is amazing. And then I've also seen evidence of what I can only describe as experimental ROAs. That's a very odd thing to be doing. I don't think it's a good practice. It's not good community either if players out there put test data into the live system and expect us to consume it and use it like it's truth. So we need to also question why people are doing that. They need to do their own experimentation. Let's not use the actual live table that everyone relies on for experimentation as well. So how does this come out? Well, rower coverage. Now, even these numbers surprised me greatly when I started looking at them, finding someone signing a /32 all the way down to 128. Yeah, that's a lot of routes. And now I've taken the obvious step of not addressing anything past 48 on IPv6, nothing past 24 on IPv4, because it's not feasible to think you can advertise such small subnets into the global table. But even said, that said, we've got a couple of nations which are signing very, very long max lengths on very large networks. And that ends up being coverage of millions, tens of millions, hundreds of millions, and even a billion subnets in the case of France. And I can tell you the slide coming up, we'll be able to name the AS that's doing that. But my simple idea here is you have your number of unique global routes over the number of completely unique subnets that your rower covers. Okay, that's everything from the prefix down to the max length expanded out. That's what I'm calling BCP 185 compliance. And every one of these economies is sitting on 0. So I'm not sure you can go back to your cybersecurity or CISO now and say, guess what? Terra gave us a 0 on BCP 185. Ouch. So in the APNIC region, Taiwan, Japan, China, Indonesia, India, Singapore, Australia. So even though Australia is doing lots of validation, Australia is doing lots of oversigning as well. And again, going down the compliance column, we get down to Thailand. Thailand is the best on this list, but it's still only 5% compliance on that metric. So that's something to be aware of. So there's a lot of work for APNIC community here to start minimalizing your rowers. So I thought this initially would be some sarcasm, but I now think I should actually delete the sarcasm detected sign, because this is a list of 25 economies which actually have achieved what we want with minimal rowers. And there's a few there that are in the 90s or even 100%. So every single subnet that they have in the global table has a signed rower, and they do not have any extra signed rowers. So their global table presence matches almost, in some cases, perfectly what they've signed as their ROAs. And you think about this with our nirvana of RPKI, where we have 7,000 transit providers on the planet all doing ROV, these 25 economies are in the prime position to protect their subnets, because if someone leaks their routes, if someone tries to forge their routes somewhere else, when they're outside of the ROA space, ROV will catch that and will minimize the damage to those economies. So this is not really, a sarcastic good news, everyone. This is really quite an impressive feat. Now, you will lament that, yes, some of these nations are incredibly small and they don't have much address space, but think also, these are also places which have minimal capacity, minimal capability, but they got the job done. So yeah, am I making anyone feel a little shame? Just a little bit, maybe? Sorry. Okay.
SY?
Hmm?
Who's SY? Sorry.
Seychelles.
Oh my God, Terry. Okay. All right, good.
Yeah, there's odd ones like that. My favorite one in my territory is .io, it's the Indian Ocean territories, which is Diego Garcia. It's a US military base plus an airport. So yeah. Another one I found that is really, really interesting, and there's actually 63,000 of these in the current ROAs, and that's overlapping signed routes. So the supernet's there with the max length that covers a smaller subnet, and the originating ASNs are different. Not all of these are actually in the table, but they have been signed. So I think, again, if you're going to minimize your ROAs, these overlaps will disappear. Okay, we really do need people to take notice of that straight away, because this also makes no sense, because who really is the true originator of these subnets? Is it AS1 or is it AS2 and so on? Max length. I love this one. This is the one I really, really want people to stop doing. And I've not tried to shame anyone with this slide. I'm just going to give you the actual trust anchor where these are originating from. But as you can see, RIPE and LACNIC, especially RIPE in Europe, 572 unique different ASNs are originating IPv4 routes, okay, from their endpoint, with 32 as the max length. We go to V6, we can see LACNIC and RIPE are there at the top of the table again. 276 unique ASNs in LACNIC are originating out of their endpoint, okay, for RPKI. They are saying, I will validate everything down to 128. Now, that's nonsensical, because the internet itself already has a little rule in place that says we won't touch anything, smaller than 48. But someone thought it's a good idea to sign everything down to 128. So again, this is please stop doing this. This is not helping. This is actually making our job of routing security a lot harder. So again, looking at some of the more interesting subnet expansions, 100.128 got into my radar because we recently had an exchange accidentally use that for their fabric. So that was fun. But as you can see here, we've got very, very large subnets. These are /10s and /9s. They're being signed for various subnets out of various ASNs, but the max length is 24. Apologies to my chair of the SIG, because her AS is actually on that list.
Oh, it's not mine. You can thank Seattle for that. It's not me, Terry.
Oh, okay. We'll just talk to the guys in the US and say, hey, fix this. Yeah. Okay, cool. Good, easy as. But yeah, look, just taking some of these subnets and looking at what's happening. This T-Mobile subnet, only the /9 is in the global routing table, but they have advertised that they will, put out there down to the 24. One subnet. So the max length on that row record needs to be 9, not 24. It will still achieve the same thing. It will be more secure. Now, if you look at that slide where I had the French one up, who was it? Oh, sorry, I need to go back one. Sorry. Oh, okay. I've jumped ahead one slide. This is the experimental data I was talking about. This is our friends in Singapore, and they've taken a single, rather large subnet in V6, and they have signed a number of combinations of it from 34 all the way down to 128 with, again, matching prefix lengths. But ultimately, this is a meandering down the tree under the 2001 C10 subnet, and they have put several hundreds of these into the rower signing table. Now, of course, no one's going to be accepting a 126 from Singtel anywhere, let alone validate it down to 126 as well, are they? So this sort of data doesn't belong into something that we as a community are relying on as a source of truth. Okay, we want things in there to be fundamentally true, not this experimental guff that's sitting here. And of course, yes, here we go. So our main offender in France is AS 5511, also known as Orange. So I was sitting down thinking about this. If this is what Orange actually intends to do with their routes, yep, time, okay, thank you. Yeah, this is a very sad state of affairs. And even at the bottom of the list, we can see another AS. They've got a /26 there. That's quite a large subnet of IPv6. And they're declaring that it's signed all the way down to 128. Now, splitting up that subnet into what is basically a billion routes, there's no one in this room, there's no one who's operating a network globally who's going to accept a billion routes from Orange, is there? It's not going to happen. So this sort of record that someone's putting online as their signed rowers is completely nonsensical. So again, let's stop this from happening. Now, my ask here is pretty simple. Go read BCP 185, minimize your rowers. If you need help, go ask. And of course, stop putting bizarre, interesting things into what is supposed to be a source of truth for our routing security, and actually treat it like it is, something that makes the internet more stable as opposed to playing with it. Questions?
Thank you so much, Terry. I'm glad we didn't do too bad. Actually, we did really well in Oceania. I'm impressed. We're running out of time, so I'm just going to take one question for you today, if that's okay.
Yes.
And also, when you said go ask on that last slide, is that go ask?
Yes, you
Okay.
you can ask me, you can go to someone from Manners. Yeah, definitely. I'm more than happy to help out. APNIC trains around this. So yeah, go for it.
Okay.
Ask.
Who's got a question on all that data?
Oh, Phil's got a question. Okay,
Go
good.
for it, Phil.
No one else does. So we found a lot of the reasons some companies out there sign, let's talk IPv4 because it's easier to speak about, /16 down to a /24, is that they use a third-party DDoS protect system, something like Akamai. How can that be resolved? Because obviously people can't wait up to an hour or even longer sometimes for them to add an ROA to something for their DDoS scrubbing to take effect. What is the go forward with that, with this platform? Because also, and my second question on that,
Yeah.
when you go create a ROA in AppNIC, you can sign a /16 and you can specify max length. So it does everything up to a /24. Is there some way in that platform to go, I want a /16, but I don't want everything up to a /24. I want all the /24s as well.
Well, you would just simply create separate records for the 16 and the 24s if you wanted to do it that way.
Yeah, which would be 200.
Yeah.
It'd be a lot.
Yeah. And I've got serious questions for DDoS mitigators who think it's okay to pollute the global routing table in that way. What they should be doing is thinking, well, if I'm going to be doing DDoS mitigation, I need to use a pathway, okay, through networks that doesn't rely on what should be going on, okay, because they need to deviate from that. Think of it as a fourth RPKI state. We need to have a don't care state. That is, we'll accept the route, we'll process it because we're doing something special with it. It's going to be sending traffic to somewhere that's normally not supposed to be going. So that's not a validity question. It's an emergency, let's fix this problem, scenario. So again, think of it like if you want to do DDoS mitigation and ROV at the same time, it doesn't make sense. You pick one. Okay. And of course, if you're doing black holing, black hole routes, okay, should obviously bypass ROV because they're a special case. So I'd say, we need to talk to these providers and say, hey, maybe you should try an idea where you don't necessarily ROV this stuff, you do something else. And then when you do need to actually advertise something somewhere, we look at doing an API or something like that to publish the rower properly. I know Anton's crew are working on an API to help us do that, reasonably at scale, but ultimately, you pick one. What are you doing? You're doing DDoS or you're doing routing security?
Thank you, Terry. Really appreciate you being here, and that data is invaluable. Appreciate
Thank
it.
you.
Okay, so last speaker, 15 minutes to go. Sorry, Chris, we are going to get you to talk fast. I am ending our program today by giving you a new idea. I feel that everybody here should have a right to be able to give us new ideas so we can think about it and discuss it and give feedback on it. And you also have to be quite brave to present a new idea to this audience. I do admit that. So Chris Hawker has come to present one, and he's really interested in your feedback. Also, well, I've got a second. If next time for all of these routing security SIGs, I'd really like to hear new ideas. I encourage you to all try, submit even to the mailing list or to me for the call for papers. We will take, it's something we're really interested in because, and I think it's going to be a nice way to finish this program. So Chris, please come up.
Thank you, everyone. The one thing I do ask is that you hold off on coming after me with your torches and pitchforks until I have finished. Okay, so my name's Chris Walker. I come from small Sydney, Australia. I'm primarily a network system administrator for a small company. And my special interest is in this world of IT, or this part of the IT world. Now, today, I wanted to talk about whether or not we can use our ROAs to replace LOAs. Now, actually, I'll see if this works. Yep, perfect. There we go. Now, what are LOAs? An LOA, or a letter of authority, is a document that's used to demonstrate authority to announce or re-announce IP space. Now, while we were conducting research on this, we had a lot of people that said that's not what LOAs are used for. LOAs are used to grant consent or authority to establish cross connects in data centers. From what I've seen back in Australia, especially with some smaller network operators, they do require, or they do ask for LOAs to be provided to demonstrate that authority. And they have been used for approximately the last 2 decades, and they started off back when network operators were small and everybody knew everybody else in the room. Now, what are ROAs? I'm not going to go too much into this. I'm going to try and speed run through this presentation with the time that we've got. But ROAs are cryptographically signed objects under RPKI, which allow network operators to determine what AS numbers are permitted to be announced from which prefixes. Benefits to using ROAs is that network operators can automate their prefix filtering based on route object validation and BGP prefix filtering mechanisms. Now, the problem, why are we looking into this? With LOAs, there is a heavy reliance on confidence-based acceptance of information on LOAs. They are extremely easy to falsify. Anyone can create an LOA for any route with any origin AS in any word processor, for that matter, and submit it to their upstream carrier. It also requires additional work to verify the components of the LOA. So you've still got to go have a look at your whois databases. You've still got to, reach out to or take a look at IRR databases and such. And if you wanted to withdraw those routes, more often than not, you would need to submit a second letter to manually withdraw those routes. Now, a real world example of a fake LOA. I do have to give credit to Yoshinobu Medazaki for his presentation at SANOG regarding this. So I've drawn on that real world example here. Back on the 21st of October, 2014, Internet Initiative Japan received a /16 prefix. And on the 5th of January, 2015, IXPX out of the US began to announce IIJ's /16 as to /17 v4 prefix routes without authorization. On the JANOG mailing list, someone posted that these routes were being announced, although they weren't expected. And so IIJ's contacted ISPX to withdraw the routes on the 4th of February and again on the 6th. And the routes were finally withdrawn on the 7th of February, 2015. Now, when the investigation was being conducted, IXPX received an LOA from one of their customers for the prefix. So ISPX was announcing these prefixes from their AS that their customer had asked them to announce. IIJ had never authorized these announcements. The company on the LOA was a family company of the former provider, so it was a sister company of the last holder. Email addresses on the LOA were incorrect. The domain name was only newly registered in 2014, and the phone number was completely wrong. Contact with the former resource holder confirmed that the domain name was not theirs, nor had they ever used that domain name. So ultimately, if it looks like a fake and it smells like a fake, it's a fake LOA. Now, on to the survey. Aftab Siddiqui and I reached out to several network operator groups over a 2-month period, sort of mid-November 2023 to mid-January 2024, just to speak to the community and get some feedback regarding using ROAs to replace LOAs. We surveyed individuals and representing a total of 61 unique networks who had 51 different upstream providers. Some respondents didn't answer all the questions, so we've taken that into account as well. Now, when we asked the respondents or the participants of the survey as to why they were asked to provide an LOA, the vast majority of them, or 28, said that they had to provide an LOA to confirm ownership or authorization, which is common practice with LOAs. 10 stated it was to validate downstream routes. 8 stated that it was to comply with regulatory requirements and industry standards. And 5 stated that they were simply for other smaller reasons. Now, with the LOA format, we asked what format the networks had to provide their LOAs in. 24 upstreams requested LOAs on an official letterhead in a PDF format sent as an email attachment. 6 required an email from just a simple email from a corporate email address. 1 accepted an email saved as a PDF from the original resource holder. And 1, most interestingly, because it would have been the easiest one to create, was a plain text file that was typed up in Notepad. Now, with understanding LOAs, the only way LOAs are going to be effective is if the people using them and the people receiving them truly understand what they're about and how they work and what their intended purpose is. We asked respondents about their level of understanding of LOAs. We had 42 had said that they had a clear understanding. 3 had a moderately clear understanding. 3 had either somewhat not a clear or unclear or just completely didn't understand what an LOA was at all. 13, unfortunately, did not answer the question. Now, security of data contained within LOAs. LOAs do hold some important information that we do need to, protect. And network operators need to be assured that that the data contained within those LOAs is only going to be used for the intended purpose, and that's to demonstrate authority to announce those IP resources. When we asked network operators whether they were how comfortable they were with providing information contained on LOAs, 30% were very comfortable that they were only going to be used for their intended purpose. 5 were somewhat comfortable. 6 were moderately comfortable. And 7 were just not comfortable at all providing the information required on the LOAs. Now, some challenges with using LOAs. We asked whether or not network operators that had to provide LOAs encountered challenges with doing so. 36 respondents had no issue whatsoever using LOAs. 11 did and did have some concerns regarding it, and 14 did not answer the question. Some of the concerns that were had was that when it came to using LOAs, these network operators, the upstream peers, required an alternate method of authorization as well as the LOA, regardless of the LOA being provided. LOAs can be falsified rather easily, which sort of led to people questioning whether or not an LOA is really secure or not. Networks are unable to provide upstreams with prefixes being advertised by their downstream peers due to those downstreams not providing LOAs. So in other words, if, say, for example, say Jocelyn was a downstream customer of mine and she didn't want to provide me with an LOA, I could then not provide that to my upstream peer. And delays with addition of authorized routes to route filters and subsequent withdrawals of prefixes. So in other words, if you wanted to withdraw a route from or if you wanted your upstream carrier to either cease advertising that route or to withdraw the route, whatnot, it would take time for them to do so because you would have to submit another document requesting that they withdraw that route. Okay. Are LOAs really necessary? 11 believe that they are essential with ensuring the security and stability of their service. 13 felt that they weren't really necessary. Are there risks with providing LOAs? 29 respondents were not aware of any potential risks, while 19 of them were. There are some risks involved. One of them being that LOAs do not demonstrate whether a prefix has been delegated by an RIR. So is it a bogon prefix, for example? We asked operators what their understanding of an RPKI is or was. 41% of respondents answered rather correctly and said that RPKI associates prefixes with an origin AS using digital certificates. We also asked respondents what their level of familiarity was with implementation and usage of ROAs. 31 respondents were very familiar with implementation and usage of ROAs. Now for the big question, can ROAs be used to replace LOAs? 29 respondents said yes, 3 said that no, they cannot. 10 believe they can with additional verification steps, and 6 were simply not sure. Can ROAs be used for legal verification? So in other words, can they be, used, in a legal jurisdiction? 25 agreed that yes, they could, whereas 6 were not sure if they could be or could not, and 3 did not believe that they could be at all. Now, the I in RPKI does not stand for identity. This is not designed to verify that an entity has the right to use the prefixes. This is simply to ensure that the routes being sent or the routes being advertised are originating from the AS that they're supposed to be originating from. And we did have some additional comments, and we gave some people the opportunity to provide their 2 cents worth. Some of those comments were newer networks that form post-exhaustion and leased space from transit provider won't be able to have ROAs created for these prefixes due to them not being an RIR member and not having access to the RIR's RPKI infrastructure. Autonomous system provider authorization, ASPA, would probably also be needed to completely replace LOAs. If a ROA exists for a given prefix, it suggests that a validator resource holder has given consent for the use of the prefix by the specified AS. And overall, I believe that this will cut down on errors, route hijacks, and implementation time. Thank you very much.
Thank you, Chris. And we made it with 27 seconds to go. So I don't believe, unfortunately, we have time to questions for you. So what I'm going to suggest is, Chris, if you could on the break stay outside on the floor, have a cup of tea. And anyone that's got a question, can you please approach Chris outside the hall? And then I would like to say thank you. That's the end of the Routing Security SIG. And can everybody who's not on the mailing list now, go to the APNIC website, find the SIG, join the mailing list. I'd love to have you there. I'd love to have more chatter on the mailing list. And see you all later. Bye.